SwayamPrabha. Digital India. Educated India.
Introduction to Textile Effluent. Lecture number 1. To begin with, let us first understand what is textile effluent. Textile effluent means that the wastewater which is generated from the wet processing is then let out, and that letting out of the wastewater is called textile effluent. Textile effluents are major pollutants. Textile industries are responsible for one of the major environmental pollution problems in the world, because they release undesirable dye effluents. Now, we all know that we cannot do without textiles. We need garments, and therefore, textile has to be dyed or processed to convert it into garment. Textile wastewater contains dyes mixed with various contaminants at a variety of ranges. Therefore, environmental legislation commonly obligates textile factories to treat these effluent before discharge into the receiving water courses. Now, strict legislative rules have been laid down by the Environmental Ministry that textile factories cannot let out their effluent without treatment. The treatment efficiency of any pilot scale study can be examined by feeding the system either with real textile effluents or with artificial wastewater having characteristics which match typical textile factory discharges. A typical and real characteristic of textile effluents and also the constituents including chemicals used in textile wet processing. So, what it means that all the chemicals that are used in the wet processing, the remnant of that which is discharged in the wastewater needs to be addressed, and those are the major pollutants and they have to be taken into account. Textile wet processing. As textile industry is one of the largest industries in the world, and different fibers such as cotton, silk, wool as well as synthetic fibers are all pre-treated, processed, colored and after treated using large amounts of water and a variety of chemicals. There is a need to understand the chemistry of the textile effluents very well. Only when we understand the chemistry of the textile effluent, then only we can think of its remediation or any kind of treatment that is required before they are discharged from the factories. Every country is aiming at common effluent treatment plants for the development of zero discharge solution for the bleaching and dyeing units. The total effluent treatment capacity is designed based on the mill size, based on the effluents generated in these mills. So, there are two major factors. One is the mill size and the other is the type of textile effluent that is discharged from each of these mills, because the chemical processing or the wet processing in every mill is not alike. Selection of technology and design for the engineering for the CETP, that is the Common Effluent Treatment Plant, are pipeline for effluent conveyance, pre-treatment works, reverse osmosis plant, evaporator plant, and recovery water distribution system, and many more advanced technologies. So, it is a concerted technology that is to be taken into account. You cannot say that all CETP work on the same principles, but more or less they believe, or they have to be treated, the effluent has to be run into pre-treatment works, then reverse osmosis should be taking place, there should be an evaporator, and there should be a system for recovery of the water, and so many advanced technologies are adapted for all this. Now, understanding textile waste characteristic is very important at this stage. The textile waste characteristic needs to be understood very clearly. Different methods and aspects of textile effluent and its management to save the environment from polluting the same needs to be understood very clearly. Major pollutants in textile wastewaters are high suspended solids, chemical oxygen demand, heat, color, acidity, and other soluble substances whose chemistry will be emphasized. So, one thing has to be understood, that first we have to understand what are the high suspended solids, that is the total suspended solid TSS, and the chemical oxygen demand, the COD, because these are two major factors which are the main pollutants, and then of course comes the heat, color, acidity, and so on. The pollutant features textile waste differ widely among various organic substances such as dyes, starches, and detergents in effluent, which undergo chemical and biological changes which consume dissolved oxygen from the receiving stream and destroy the aquatic life. So, they use the oxygen which is dissolved in the water bodies, thereby not making it available for aquatic animals in that water stream, and therefore they start dying, and that is how the aquatic life gets destroyed. Such organics should be removed to prevent septic conditions and avoid rendering the stream water unsuitable for municipal, industrial, agricultural, and residential uses. So, we have to keep in mind that as long as these dyes are present, or these detergents are present, or these stars are present in the effluent, they are not going to let the dissolved oxygen be available for aquatic life, and therefore they will create a septic condition, and they will not be suitable for municipal or industrial or agricultural or residential uses. Now, let us understand what are the harmful chemicals that are used in textile industry. The common question would be, why do we use them? We use them because they are mandatory to be used for certain wet processes. Hence, we cannot eliminate them completely. However, we can reduce the quantities or look for a remediation in the effluent. So, among the list of harmful chemicals that are used in textile industry, detergents, mainly nonyl phenol ethoxylates, generate toxic metabolites which is poisonous to fish. Stain remover carry solvents like carbon tetrachloride, can cause ozone depletion. Oxalic acid used for rust stain remover are toxic to aquatic organisms, and also they boot the COD, they reduce the COD, that is the chemical oxygen demand. Sequestering agents like polyphosphates of the type trisodium polyphosphate and sodium hexametaphosphate are banned chemicals, yet they have to be sometimes used. Printing gums, preservatives like pentachlorophenol can cause dermatitis, liver and kidney damage, and are also banned chemicals, but sometimes these chemicals have to be used. Among the other list of harmful chemicals are fixing agents. In the category of fixing agent, formaldehyde and benzidine, which are banned internationally, are also very crucial. Bleaching agents like chlorine bleach can cause itching and is harmful. Dyes, the azo dyes which release amines are banned because they are known carcinogens. And why they are known carcinogens? Because they release primary amines after the breaking of the azo N double bond N, and that is how these amines are highly toxic. Textile effluent or wastewater, we will call it in abbreviation TWW. Textile wastewater is one of the most important hazardous wastewaters for ecosystems, which it is discharged directly into water streams without proper treatment. Textile effluent is heavily contaminated with pollutants such as dyes, dissolved solids, suspended solids and toxic metals. The main factor to be considered in textile effluent is the total dissolved solids, that is TDS. Because of the use of common salt and Glauber's salt, the level of TDS increases in textile wastewater. Color, odor, temperature, pH, total dissolved solid, that is TDS, dissolved oxygen DO, chemical oxygen demand COD, biochemical oxygen demand BOD, and electrical conductance EC are major characterizing physiochemical parameters of the textile effluents, which need to be tested before this water is discharged into the water bodies. Now, what is textile effluent? Let us try to understand very carefully the meaning of that and what textile effluent brings along with it, its characteristic. Textile effluent refers to wastewater discharge from textile manufacturing processes. It contains various chemical substances, dyes and pollutants derived from the production of textiles, including fabric, garments and other textile products. So, any type of textile product will have to go through the wet processing, and if it goes through the wet processing, it is bound to generate textile effluent. So, it is always that if we are making fabric or garments or textile for any other use, the textile effluent will be generated. Textile effluent is a significant environmental concern due to its potential to pollute water bodies, harm aquatic ecosystems and pose risk to human health. The key aspects related to textile effluent are its composition, and in the composition, textile effluent comprises a complex mixture of organic and inorganic compounds. including dyes, heavy metals, solvents, salts, acid, alkalis and other chemicals used in textile processing. These substances can have detrimental effect on the environment and human health if not properly treated before discharge. So, it is a very serious matter. These chemicals, although they are very useful in textile processing, but they can be extremely harmful to human health. Then comes the pollutants. These pollutants, when they are discharged through the textile effluent, introduces various pollutants into water bodies such as rivers, lakes and oceans. These pollutants can include toxic chemicals that are harmful to aquatic life, disrupt ecosystem and contaminate drinking water sources as well as sometimes soils. Environmental impact caused by TWW, that is textile wastewater. Environmental impact of this textile effluent contributes to water pollution, which can have far-reaching environmental consequences. It can degrade water quality, affect biodiversity, disrupt aquatic ecosystem and harm organisms which are living in or are dependent on the affected water bodies like the river, the ocean and the lake. Health risk: exposure to untreated textile effluent or contaminated water sources can pose health risks to both human and animals. Chemical presence in textile effluent such as heavy metals and dyes may have toxic effects and can accumulate in the environment and food chain, potentially causing adverse health effects. So, it has serious implications. We cannot take this very lightly, and hence to understand the textile effluent, the nature, the characteristic is very important. Regulatory measures: governments and environmental agencies enforce regulation and standards to control the discharge of the textile effluent and minimize its environmental impact. These regulations often include requirements for effluent treatment, wastewater management practices and limits on pollutant concentration in discharge water. So, they have made rules as to what is permissible, how much should be remaining in the water before it is discharged. That is, there is a stipulated value for each of these chemicals which are known pollutants in the effluent. Then only we can think of treatment technologies. So, there are several treatment technologies. Various treatment technologies are available to treat textile effluent before discharge. These include physical, chemical and biological processes aimed at removing or neutralizing pollutants and contaminants present in the wastewater. Common treatment methods include sedimentation, filtration, chemical precipitation, biological treatment such as activated sludge processes and advanced oxidation processes. So, new and newer methods are being developed for the treatment of the textile effluent, because as long as man exists on this earth, textile will be required, textile processing cannot be stopped, and textile processes are going to use chemicals which are eventually harmful for human or even animals. Sustainability initiatives in response to growing concern about the environmental sustainability, many textile manufacturers are adopting more eco-friendly production practices and investing in technologies to reduce the generation of textile effluent and minimize its environmental impact. This includes the use of less harmful chemicals, water recycling and reuse, and implementing closed loop system to minimize wastewater discharge. So, there are not only treatment technologies which are being developed, but there are other sustainable processes which are being projected and practiced by the mills, because they believe that the lesser the discharge, the lesser is the problem or the susceptibility of contamination. Overall, understanding and addressing the challenges associated with textile effluent are crucial for promoting sustainable practices in the textile industry and safeguarding the environment and public health. So, in order to understand this, one thing is clear, that treatment technologies and sustainability initiatives have to be done, because then only they can be overcome through these contaminants and removal of the contaminants. The wastewater characteristic of textile effluent should be understood, and in order to understand, let us go one by one. The wastewater characteristic of textile effluent can vary depending on the specific processes involved in textile manufacturing, as well as factors such as types of fibers, dyes and chemicals used. However, textile effluent typically exhibit certain common characteristics. That means, we have certain common characteristics which are always present in the textile effluent, and there are some specific chemicals which are used for specific processing. Let us first look at the typical common characteristic of textile effluent. One is color. Textile effluent is often highly colored due to the presence of residual dyes and pigments from dyeing and printing processes. The color intensity can range from pale hues to vibrant shades depending on the type of dyes and concentration of dyes used. And this is very apparent. One can look at the effluent and say, okay, it is very highly colored or less colored. And especially, let me tell you here that printing effluents are the most notorious textile effluent, because the type of chemicals that are used in printing are far more in number and very difficult to remove in the textile effluent treatment. So, they are very notorious and their removal is very tough. Then comes pH. The pH of the textile effluent can vary widely depending on the specific processes and chemicals involved. Textile wastewater may be either acidic, neutral or alkaline depending on factors such as the use of acidic or alkaline chemicals in dyeing, bleaching and finishing processes. Chemical oxygen demand, COD, it is a very important factor when we are considering textile effluent. Textile effluent typically has high COD, which indicates the amount of oxygen required to oxidize organic and oxidizable inorganic compounds present in the wastewater. The high COD of textile effluent is primarily due to the presence of organic substances such as residual dyes, solvents, sizing agents and other organic chemicals used in the textile processing. Main parameters that need to be checked: biochemical oxygen demand BOD. BOD measures the amount of dissolved oxygen consumed by microorganisms while decomposing organic matter in the wastewater. The textile effluent often has high BOD due to the presence of biodegradable organic compounds such as starches, sugar and cellulose derived from natural fibers and processing chemicals. Then comes total suspended solids TSS. Textile effluent may contain suspended solids such as fiber, lint, dye particles and other particulate matter generated during various manufacturing processes. TSS levels can vary depending on factors such as the type of textile production, equipment used and wastewater treatment practices. Heavy metals. Textile effluent may contain heavy metals such as chromium, lead, cadmium and copper, which are used in textile dyeing, finishing and other processes. These metals can be toxic to aquatic life and pose risk to human health and environment if not properly managed and treated. So, this is quite serious because heavy metals are going to create even more serious problem in the textile effluent and particularly for the aquatic life as well as for human health. They damage the environment terribly. Salinity and TDS. Salinity and total dissolved solids, that is the TDS, in textile effluent may have elevated levels of salts and dissolved solids, particularly if salt based chemicals such as sodium chloride are used in the processes like dyeing and printing. Often as a equilibrating agent, sodium chloride is added during dyeing. High salinity and TDS levels can affect water quality and soil fertility if discharged untreated into the environment. Toxic chemicals. Textile effluent may contain various toxic chemicals such as formaldehyde, chlorinated compounds, aromatic amines and other hazardous substances used in the textile processing. These chemicals can pose risk to human health and environment if not properly controlled and treated. So, again and again I am bringing this problem of human health and environmental damage due to textile effluent. So, it is a serious matter and we need to understand the characteristic and the nature of textile effluent in order to find a solution. The wastewater characteristic of textile effluent can vary widely depending on factors such as the type of textile production, the chemicals and the processes used, and the efficiency of wastewater treatment measures implemented by textile manufacturers. So, what it means that any textile manufacturer will now have to look at the wastewater treatment measures more seriously than before because of the legislation laid down by the Environmental Ministry. Effective management and treatment of textile effluent are essential to minimize its environmental impact and protect water sources and public health. If we look at this slide, we will see that sizing, desizing, scouring, bleaching, mercerizing, dyeing, printing, finishing, all these processes use so many chemicals and cause so much of pollution in the wastewater. So, desizing causes biochemical oxygen demand from the sizes, enzymes, starch and waxes. Then during bleaching, hydrogen peroxide, sodium silicate, organic stabilizer and alkaline conditions all are required during the bleaching process. In the scouring process, we have sodium hydroxide, surfactant, soaps, fats, pectin, oils, sizes and waxes. In the dyeing, we have metals, salt, surfactant, colors and alkaline or acidic condition. In the printing, we have color, metal, urea, formaldehyde and solvents, and as finishing agents, we have softeners, solvents, resin and waxes. So many different varieties of chemicals are being used in the processing, wet processing of textile. Hence, the composition of textile effluent is to be understood from the mill's production point of view. The effluent discharged from the textile factories are a mixture of dyes, metals and other pollutants. The colorants can be divided into natural and synthetic dyes. The synthetic dyes are produced easily in different colors and characterized by their fastness, which makes them more widely used than natural dyes. Synthetic dyes are classified into different groups or according to their chemical structure, that is azo, anthraquinone, sulfur, phthalocyanin and triaryl methane according to their structural shape, and according to their mode of application they can be reactive dyes, direct dyes, dispersed dyes, basic dye or vat dye. The dye effluent are high in color, pH, suspended solids that is SS, chemical oxygen demand that is COD, biochemical oxygen demand that is BOD and salts. So, this is more or less the composition of the textile effluent. It may vary from one component may be higher, the other component may be lower from mill to mill, but in general the dye effluent will be colored. It could be highly colored, it could be less colored, it will have pH, it will have suspended solids because of the dissolves and suspended solid material, it will have high COD and BOD, and therefore, these are more or less the common characteristics of the composition of the textile effluent. Therefore, during the treatment processes, it is important to monitor and compare these parameters with the standard concentrations before discharging the corresponding effluent to the receiving water body. Monitoring of the treatment performance regarding other parameters such as total organic carbon that is TOC, ammonia nitrogen which is NH4N, nitrate nitrogen which is NO3N and orthophosphate phosphorus that is PO4P is also required simultaneously. Textile wastewater problem. Textile treatment of this is very important. If we do not treat the textile wastewater, it will definitely increase the waste. Hence, we need to treat the wastewater definitely, which will reduce, prevent and make positive effects on its further uses. It can be recycled if it is purified enough and if it does not have any color remnants. Strong rinse water from dye operations may be used to make up new dye bath, while weak rinses may be recycled through in-plant water treatment units. So, depending on whether they are high in color or they are low in color, their recycling or treatment strategies can be changed. The savings in material in the first case may be enough to pay for the cost of the treatment of the latter case, which means that whatever money is involved in recycling can be compensated if we use the highly colored discharges for making new dye baths and adjusting the color concentration through color scan machine. Chemicals that are used in chemical industry, that is synthetic organic dyes, bleaching and detergents. Some chemicals are biodegradable such as starch, however, others such as dyes are non-degradable. Thus, the effluent could have lower dissolved oxygen concentration, which means they will cause higher BOD and COD. Solids in textile wastewater come from fibrous substrates and process chemicals, thus disturb the aquatic life by showing oxygen transfer and reducing light penetration. So, if the water has too much of dissolved solids, it will not let the sunlight penetrate through the water body. As a result, aquatic plants may not get enough light to carry out their photosynthesis, and therefore, they will die or they will become pale. Therefore, it is necessary that the salt should be removed, the TSS should be lowered. Inorganic chemicals used. High concentration of soluble inorganic salts may make the discharge water stream unsuitable for industrial and municipal use. Metals such as chromium and zinc are toxic to aquatic life and should be removed before discharge. Certain carrier chemicals used in dyeing such as phenol may add bad taste and odor. So, we have to see what are the chemicals that can be reduced if not removed completely from the processing system. Therefore, we understand that treatment of textile effluent is mandatory, is essential. Typically, textile effluent would involve the following steps. Reactive dye concentrates can be treated in a conventional anaerobic digester. Exposure to the biomass to achieve decolorization and tolerance of microorganisms to concentrations of the dye. So, there are methods of treatment, but the method of treatment has to be chosen according to the kind of effluent that is present or the kind of composition of the effluent that is present. Additionally, carbon source such as glucose is necessary to maintain the microbial metabolic state. The presence of nitrate in the system inhibits decolorization. Adsorption of dye to the biomass also causes decolorization. The degradation products of the dye after anaerobic digestion may be isolated and identified. So, there is more complexity to it. It is not so simple to remove all these very easily and with with a twist of the finger you can just remove. It is not like magic. It needs a concerted planning, and the treatment plan is based on the composition of the textile effluent of that mill. There is no universal formula. So, the treatment of the wastewater, after every effort that can be made to reduce waste strength and volume, there still remains the problem of disposing the final remains of polluted waste into any water body. Thus, the waste may be treated in various methods, either singly or in combination, and the best combination of methods differ from plant to plant. The various types of treatment practices that are followed are segregation, lagooning and storage, screening, mechanical filtration, pre-aeration and post-aeration, neutralization, chemical precipitation, chemical oxidation and biological oxidation. So, one can choose one of the methods, or one can use several of the methods. That discretion is left based on the composition of the textile effluent. Major environmental concern: the removal of color from the textile industry and dyestuff manufacturing industry wastewaters represents a major environmental concern. Conventional oxidation treatment have found difficulty to oxidize dyestuffs and complex structures of organic compounds at low concentration, or if they are specially refractory to the oxidants. To ease the stated problem, advanced oxidation processes, that is AOPS, have been developed to generate hydroxyl free radicals by different techniques. AOPS processes are combination of ozone, that is O3, hydrogen peroxide H2O2 and UV radiation, which showed the greatest promise to treat textile wastewater. So, among various processes, the advanced oxidation processes show a lot of promising result in terms of treatment of textile effluent. Currently, what are the practices which are being practiced in the textile industry to reduce the pollutants in the textile effluent? The textile dyeing industry is under considerable pressure to reduce the color of the process water directly discharged to municipal water treatment facilities. Two common approaches are practiced. One is the electrochemical treatment by anodic oxidation, using anodes with catalytic coatings to oxidize the dye waste, and the second one is ion exchange zeolite treatment with different cations such as Fe2, Fe3, copper 2, clignotillolate, a natural zeolite, have been found to be quite effective. Since the catalytic Fe2 sites are bound to the zeolite structure, no sludges are formed, and the cation released to the solution during the organometallic dye degradation were found to be absorbed by the zeolite. So, here there is an advantage that the zeolite structure is so beautiful that whatever is being precipitated are actually absorbed by the zeolite. The most versatile oxidation or biological oxidation method for treating textile waste is activated sludge process. In this process, the textile effluent after primary treatment is fed to an aeration tank where it is subjected to continuous biological degradation by microbial flocks suspended in the reaction tank. Now, this is of common practice that biological oxidation for the treatment of textile effluent by using activated sludge, it is of common occurrence. Every textile mill which has its effluent treatment plant will have this unit, and therefore, microbial flocks are suspended in the reaction tank and they are allowed to stay for certain number of hours, where they are able to degrade the chemicals that are present in the textile effluent. Commonly combined for the treatment of effluents. As I stated earlier also, no single process is foolproof. That we do one process and the water will become colorless, odorless, and will have neutral pH and all of the qualities that a unused water is having. Therefore, sometimes we have to use combination of methods. The textile industry uses a significant volume of fresh water throughout all processing operations, dyeing, bleaching, washing, while it continues to freshwater pollution during the thorough washing of the fabric to remove chemicals. So, it is contributing continuously, fresh water is not remaining any more fresh water. The processes most commonly combined for the treatment of effluent generated in the textile industry are screening, homogenization, neutralization, physical and chemical processes, chemical treatment, biological treatment, and additionally filtration or evaporation technologies in cases where the treated water is to be reused. So, there are several techniques one after the other in combination which are used for the treatment of the textile effluent. A correct design of wastewater treatment system. So, what should be the correct design of the wastewater treatment system for the textile industry? That it should meet certain objectives, adapt the wastewater to the discharge limits. This is being set up by the regulatory body. So, reuse water in different textile manufacturing processes, that is washing, dyeing, heat treatment, as well as for cleaning operations, irrigation, etc. To recover raw material dissolved in the wastewater such as pigments or dyes, to reduce operating costs of the production process, to reduce the environmental impact of the business activities. So, all put together, then it becomes a good or a correct design for wastewater treatment system. Now, what is the main culprit? Which one is the most difficult to be removed? The plants for the treatment of wastewater generated in textile industry involve various technologies, since the diversity of pollutants present in the effluent cannot be treated by a single technology. This we have understood so far. Wastewater from the textile industry is characterized by the large amount of reagents applied in its production processes, most of which are non-biodegradable and persistent in medium, especially the aqueous medium. The pigments used are highly contaminating agents, as they are manufactured to offer high durability and resistance to biological degradation. Up to 200,000 tons of pigments and colorants can be lost annually in the manufacturing process if the water is not efficiently treated. It is for this reason that it is increasingly important to implement circular economy solutions that enable the reuse of wastewater and the recovery of raw material dissolved in effluents. Now, this is a very serious issue, that such a large amount of pigments and colors are still remaining in the textile effluent, and if they are not recovered, we definitely cannot talk about circular economy. And in today's time, every bit of restoration can change the entire business model of that mill, and therefore, it is very important to look at the recovery of these chemicals which can be reused in due course of time. So, what are the types of textile wastewater treatment? Textile wastewater can be treated by adsorption, wastewater treatment, membrane bioreactor, ultrafiltration, nanofiltration, phenton oxidation, microalgae and biochar. So, these are various different types of treatments that are commonly practiced either in isolation or in combination. How can you reduce the usage of water in textile production sustainability? Now, there are two things: either we use large amount of wastewater and recover it, or we use sparsely water so that less effluent is generated, less treatment is required. Choose low water fabrics, use waterless dyeing methods, recycle and reuse water, implement water management practices, educate and engage stakeholders. Here is what else to consider. Textile production is estimated to be responsible for about 20% of global clean water pollution. From dyeing and finishing products, a single laundry load of polyester fabric can discharge 700,000 microplastic fibers that can end up in the food chain. So, you imagine that such is the manifestation of the textile effluent, and if it is not managed, it can be a serious environmental problem. Use waterless dyeing methods. Dyeing is one of the most water intensive stages of textile production, as it involves rinsing, washing and disposing of wastewater that contains chemicals and pollutants, and the processing chemicals. However, there are alternative methods that can reduce or eliminate the need of water in dyeing, such as air dyeing, digital printing or supercritical carbon dioxide dyeing. Now, here the water demand itself is very low. Therefore, very small amount of effluent will be generated, or there will not be any effluent generated at all. These methods use air, ink or gas to transfer colors to the fabric without generating wastewater or requiring high temperatures. They also save energy and reduce emission. So, switching to waterless dyeing methods is definitely advantageous in reducing the textile effluent water pollution. Implement water management practices. Besides using less water or reusing water, you can also implement water management practices that can help you monitor and optimize your water consumption and efficiency. For example, you can conduct a water audit to assess how much water you use, where you use it and how you can reduce it. You can also set water reduction targets and track your progresses. Additionally, you can adopt best practices and standards that can guide you to improve your water performance, such as Higgs Index, the Sustainability Apparel Coalition, or the ZDHC program, that is Zero Discharge Program. Guide to Improve Water Program. Higgs Index. Higgs Index is a suite of 5 tools that assess and measure the social and environmental performance of the value chain and the environmental impact of products. We develop these tools to help organizations make systematic change by identifying, understanding, and measuring areas of improvement. Sustainable Apparel Coalition. The Sustainable Apparel Coalition, a global non-profit aimed to improving the social and environmental impact of the fashion industry, is expanding its new territory: home furnishing, sporting and outdoor goods, bags and luggages. Zero discharge hazardous chemicals, that is ZDHC. The use of hazardous chemicals in the manufacturing process that can be discharged into wastewater is under particular scrutiny. Numerous initiatives have emerged to address this issue, the most comprehensive being ZDHC program. So, this is the kind of layout where you have effluent from desizing, from bleaching, from dyeing, and then they are treated differently, but the most effective one is the AOPS, which is the advanced or oxidation processes, and through that we get biodegradable and non-degradable products, which then finally need to be checked and removed. So, design appropriate wastewater treatment technologies. Design appropriate wastewater treatment technologies which are removing effluent from the wastewater of textile factories to mitigate water pollution. Concerning environment, accepted technology must be applied for the treatment of textile industry effluent. Various technologies have been observed to remove dyes from water in the textile factories. In the textile industry, wastewater treatment plants are well designed by integration of various technologies such as physical and chemical, biological with chemical, and physical with biological methods, depending on the type and amount of pollutants load. Due to the cost and clogging, effective membrane filtration method limits applying dye removal, while adsorption method is preferable. Due to the low generation of byproducts like solid waste, low working costs, and complete mineralization of dyes, the biological treatment method is better than the chemical treatment method. Hence, we come to the conclusion in understanding that there has to be a good understanding of textile waste characteristic. Major list of chemical pollutants need to be identified. Parameters to check the pollutants. Wastewater treatment strategies have to be made according to the pollutants that are present in that particular effluent. Implement water management practices, guide to improve water program, and design appropriate wastewater treatment plans. Thank you.